time working on your homework. So we have homework due tomorrow. And Alex, if you haven't got that page, what is it, 10 and 13 done, make sure those get done. And
oh, it's done. I got it.
Good.
Have you seen my choice of Christmas? Are those Walmart things? No. Are those Walmart things? Is it a Walmart haircut? I got that in my shoes here at school. Is that Walmart stuff?
Only this year.
Oh, that, like your books and stuff.
No, that is shotgun.
Oh, okay. Well, this is only from Walmart. And then everything from, what's it called? It's like a fancy everything.
I have black shirt and I don't know the other.
Did you get your eyebrows done at Walmart? Did you get your eyelashes done at Walmart? Did you get your nose hair done at Walmart? Did you get your ears waxed from Walmart?
Intro to graphic design. Turk and Coogan both had to do 30 push-ups.
Yeah.
Oh,
Or no, Coogan had to do 15, Turk had to do 30.
Hey Jason, I have a question. Did you get that shirt from
Turk
Walmart?
got about
Jason.
at 25 when Coogan just finished with 15.
Jason.
No, what did they say? Why'd they have to
They
do
said,
that?
Oh.
Jason, did you get that shirt at Walmart?
Yeah.
Get those shirts from Walmart.
Okay. Alright, welcome back. I know we have homework due tomorrow, right? That's page 19. I'll give you some time today to work on that. 'Cause, I don't know how many people got it done, if any, yesterday. So I'll give you some time to work on that today, but it is due tomorrow in class. So make sure that you are paying attention to that. Let's see. Did anyone get turned in yesterday? I don't want to speak too soon. I don't think we did. Okay, good. Alright, yeah, and if you've not got page 10 and 13 done, get that turned in. I don't think I have it from, let's see,
I think, yeah.
I got it from Hannah, got it from Beth, got it from Jason, Cole, so I think Sean, you showed me 10 and 13, that was the one that was due earlier this week, so let's work on those, so. And then Alex and I, you still.
Wait, mine's not in there. Oh, I think I accidentally put an empty sheet.
Okay, so make sure that gets turned in today. Alright, good. Okay, this is not yours. Not your stuff. Alright.
I was gonna say,
Ooh,
is that
we're
geometry?
learning about
No, that's
area
pre-calc.
Pre-calc?
Pre-calc stuff. Finding volume and area, they still do it in pre-calc and algebra 2 and all that. So, we're doing the variables, finding unknowns. Alright.
Well, seriously, I should be in pre-algebra this year, but I'm just
I should be in,
saying.
what's it called? Algebra 1. Because when I was in here, I was doing
Alright.
really well, actually.
Okay. Alright, let's talk about what we're going in here, what we're into today. We're on section 1.6 today. Okay, we're doing division. Division. So the big thing is, we gotta talk about, number one, let's talk about some of the vocab words that we need to discuss. Vocab terms that could mean, vocab terms that could possibly mean division. We'll get through that. Then what we're gonna do, we're gonna talk about the particular method of how we're gonna do this. Now notice I didn't say methods. Method. The one method I want. Okay? Not right now. Not right now. You can have it out later. So we'll talk about a particular method for how we do division. Now this is gonna lead us into a topic today which we will continue until tomorrow. So, because I know like up to lunch, and then after lunch I'll give you some time where you can work on your previous assignments and stuff. But this is gonna give us a new topic. One of the topics we're gonna discuss today is, and it's not a method, it's actually something different. It's called the divisibility test. Divisibility tests. I wished my teacher would have taught me this when I was in high school, like, or in elementary or junior high. I wish somebody would have taught me before I went to college and, learned it when I was doing my educational classes. Because the divisibility test make your life so much easier. So like, you have an idea what your answer will be in the end. Like, it's a way to know, am I gonna get a crazy number? Is it gonna be a nice number? That type of thing when I'm doing division. Because I know division is like one of the most hated things in math for a while. Just hate division, hate doing long division, can't figure it out, the numbers are weird. Then it leads into fractions, because fractions and division basically mean the same thing. I know that, so I'm gonna try to make it easy. I'm gonna try to make it easy so that you understand there's different ways and different techniques that will help you to make this so much easier for you. Okay, but let's first start with the vocab terms. Let's do that. Okay, so vocabulary. Alright, so the vocab terms for division. Just so you know, so that you're not like totally shocked by when you see it. One of the words that we need to understand is called the quotient. The quotient of. Quotient means you're going to be dividing, and I'll go through some more words here in a minute. Okay, you're dividing. It's the results of division. So we'll come back to that concept of quotient and why that's a big deal. Okay, another word, divided by. These are basically it. I mean, those are the two terms these are the words that we use in class when we talk about division. I know that there's other things, like when they say half, a third, a fourth. Those are things that's very specific types of division. And in fact, I'm going to put those down below. I'll put those, with a separate marker. So when they get very specific, they could say half of an object, or a third of an object, so on and so forth. Etc., etc., etc. Okay, it's a very specific type of division. Okay, those are the basic vocab terms that I want you to know. Now, division, talking about the method, and this will lead us into more vocabulary. What method do we use for dividing? Anyone know? Like, how do I take 15 divided by 3? What's the method of doing it?
Column?
It's kind of like column method. We call it long division, but it is the same concept. It is still a column, so it's called long division. You're going to long divide. You will do long division in other classes as well. What I mean by that, like for math, obviously you divide in almost every math class, but we actually use this long division technique in pre-calc. The work you saw on the board that I was erasing when you guys walked in. Eventually that class will have to learn how to long divide using all those letters and variables and stuff. So they use the same concept that you do. Okay? Is long division. That's how we do it. Now, this is the way that most people see division, correct? You see it with like the little colon, right? That symbol. It's the same thing as putting a dash in between, making it a fraction, 15 divided by 3. But the most common way, like we said, column method, is doing long division like this. This is the way that most people see division. They put a little house, they put 3 on the outside. Okay, now these numbers, these things have names. That's what you need to realize. Okay? Like, most people when they see a fraction, there are certain names to a fraction. Agreed? Like, what's the top called? Do you know? Starts with an N.
A numerator?
Numerator, yeah. Numerator. That's the top of a fraction. The bottom of the fraction, denominator, yeah. Okay, that's fine. That's for fractions, right? But we're doing long division. We're doing this. Those have different names now. I know they're the same term, so it's literally the same numbers. These all mean the same thing. But the names over here, this number is called the divisor. It's what you're dividing by. It's the divisor. The number on the inside is called the dividend. Dividend. And I'll explain that concept of dividend, why they would call that. Okay? And the answer on the top, that is actually called the quotient. That's why they always say find the quotient of. It's literally, the quotient means the answer for division. Quotient. There we go. I can see it a little bit better. Quotient. And sometimes the quotient has what, remainders and stuff. Sometimes they're remainder. I think in elementary math, they always have they put a little R out back and they put whatever numbers are left over. Yeah. So that's a technique. We'll actually talk about that in this class, why there's a purpose for doing that. Okay, everyone understand the basic vocab terms. The reason I like to show those is so that you don't forget vocab. Vocab is very important in math, but it's also, I start using them. Like, hey, what's your divisor? What are you dividing by? That's just a simple question I might ask. Well, now you can kind of associate, the divisor is a number on the outside. Oh, I must not have that right, so I gotta go figure out what's wrong with my divisor. That type of thing. Because maybe you just mix two of the numbers together. Maybe it's just something was wrong with it. So that's kind of the idea. Typically when you do long division, the number on the inside is bigger than the number on the outside. Usually. When we start getting to the later chapters, we'll learn how can we long divide when the number on the inside is smaller. There's an actual technique there. Okay? Now, for long division, for people that are really good at division, people that actually enjoy it, they don't fear it, it's because they're really good at multiplying. If you're really good at multiplication, you will be really, really good at division. That's what you need to realize. And you also have to know how to subtract. That's another big deal. Okay? So, let's do a couple examples today. I want to do maybe one or two examples of division, and then talk you through that there's divisibility tests. Something that sometimes you don't even have to start the problem. You know that it's going to work or what it won't work. Okay? Alright, so here's the idea. Let's start with this number, the 3 and the 15, right? Doing long division. Okay? So how this works when you're setting up division. I always think about what number can you take times the divisor here? What number can I take times 3 that would get me closest to this number? Get me closest or equal to it. 5. That's how you do it. 3 times 5. And I always put whatever I'm multiplying on that 3, I put it up top. So 3 times 5, that gives me 15, right? Because you guys even said 3 times 5 is 15. So what you do is you subtract whatever those were. So when you multiply those, you subtract straight down. 5 minus 5?
0.
0. 1 minus 1?
0.
0. Done. Because that's my remainder. This is the answer. That's the quotient. That's what they're looking for. It worked out perfectly. That 3 went into 15 5 exact times. Okay, another way you can do this, because you are literally subtracting. Another way you could do this, you could subtract 3 a bunch of times. So you get to your remainder. When this number turns out to be smaller than the number you're subtracting, you could stop. So if it's 0, that's fine. And then what you do is you just count by hand, how many times did you subtract 3? How many times did I successfully subtract 3? Is that 5 times? That's why it works. Division works that way. You can subtract and figure out how many times you subtract it. Okay, I would not want to do that for bigger numbers, but I mean that's literally what it's doing. It's what division is. How many times can you break it up into pairs of 3s? Or subtract 3 off it so many times? Okay, so I guess that is a strategy. I would just never choose to do that. Okay, but let's do a different problem. Okay, I'm gonna do like the problem. I'm gonna pick one that I know doesn't work. So let's go like 123, and I'm gonna divide by the number 2. I know this is gonna work out nice and pretty. It won't. But when you see this problem, what number goes in the house?
123.
Yeah, the 123. It's not just because it's the bigger number, it's the first number. So what I always think of, like imagine that these two are chasing each other. Like they're running, and 123 is first, right? It's running, and number 2 is chasing it. This one gets to the house first and shuts the door. Locks number 2 outside. I mean, it's silly, but that's how I remember. It's like, which one's getting the house? The first number gets there first. That's how it works. And it locks itself in, so it's in the house. Okay, now, Now we can try to figure out what number can you take times 2 that would get me closest to the 123. Well, would you agree that 123 is super big? Do you agree with that? Like, it's a huge number. So it's too much work trying to think of, okay, what do you take times 2 that gets me close to 123? So what you do is you make it smaller. You do it more manageable. So instead of going the whole 123, you just focus on the first numbers. So if you can go down all the way to the first number, try that. If 2 can go into the 1, you try that, but 1's too small. So the next number is the 2, right? So this number is 12. What can I take times 2 that would get me closest to 12?
6.
6, right? And now I can subtract. Okay, I know there's a 3 on it, but I ignored it. I literally just ignored the 3. I didn't even look. I just looked at the 12. So, what's 12 minus 12?
0.
0, right? Well, I'm not done yet, because I still have this number that I didn't use, so I just drop it straight down. That's how long division works. Whatever number you did use, you just drop straight down. And I don't care if there's 3 numbers back here, you can drop them straight, but I just always do 1 number at a time. That's just how I always do it. That's how I've learned it. Okay, now we start over. What number can I take times 2 that would get me closest to the number 3 without going over? 1. 2 times 1 is the number 2, right? 2 times 1 is 2. And now I subtract. What's 3 minus 2? 1. That's my remainder. There's no other numbers I can drop here. That's my remainder. Most people just do this. They just put a little r, they put the remainder after it. That's fine. That's literally what you can do. I'm totally fine with you doing that. It's good practice, in fact. I don't want decimals. I don't want crazy fractions. I don't want anything like that. This is acceptable to me. Okay, any questions with how I did this? Okay, we will practice this more. Okay, we will practice this. Now, I want to talk about, people that are successful are very good at multiplying. You can even see this, like, what do you take times 2 that gets you closest? And then you have to subtract. Subtracting and adding is not a big deal, but multiplying is the key. People are really good with multiplication facts, know how to do long divide, because they always know what goes into it. Never have to think about it. Also, this second thing that I talked about, divisibility test, this will make you successful at division. Because like I said earlier, I knew before I started that problem was not going to be pretty. I said it out loud even, that 123 divided by 2 was not going to work. Because I know there's certain tests in math, before you start a problem, will it work? Will it work or will I have a remainder? That's the type of thing I want to talk about, okay? And this is the divisibility test. So I'd like you to write these down somewhere in your notes if you can. We're going to start with the first half of them today, the first half. We'll do the second half of the test tomorrow, okay? These are pretty easy. I'm going to stick with just the first few. I'm going to go through like the number 6. That's what I'm going to do, okay? All right, so divisibility test. Okay, so this is if you're taking a number and you're dividing by a small number. Now, if you're going to divide by the number 2, you're going to divide by 2. Here's how I know it will work if you're going to divide by 2. Will it work or not? Is your last digit, is the last digit of the number you have, the dividend number, the number in the house. Okay, so look over there. What's the number in that house over there? The 123? Look at the last number on it, the 123. The last digit is what, a 3, right? Okay, if your last digit is a 0, 2, 4, 6, or 8, it will be divisible by 2. It'll work out perfectly. It'll be a whole number, you'll have a remainder of 0. What was my last number again?
3.
It was a 3. It didn't end in a 0, 2, 4, 6, or 8, so I knew there was going to be a remainder on that problem. That's how it works. So whatever your house number is, the dividend, is the last digit of 0, 2, 4, 6, or 8. If it is one of these numbers, I can divide it by 2. So somebody make up a number that ends with one of these. Any number in the world.
226.
Boom. The last number was a 0, 2, 4, 6, or 8, so I know it's divisible by 2. You see how easy that is? You can make up any number. It could be 1,000 numbers long, as long as the last number is important. Okay? Alright, next test. The 3. Is your number divisible by 3? I think I did the 15 earlier. Alright, here's how it works. Whatever your dividend is, so look at the number in the house. So we're going to go in here, the number in the house. Okay? What you're going to do is you're going to add, you're going to sum all the digits together. So that's what I want you to do first. So when we were doing this problem, we're trying to divide by 3, and I was using the 15. This is the number in the house, right? What do you get when you add these digits together, 1 and 5? What do you get when you add the 1 and 5 together?
Oh, yeah. No, 9.
Say it again. 1 and 5 added together?
6.
6, thank you.
6. I was
You
doing
get
that.
6. Alright, so that's, I'm adding the 1 plus the 5. Right, you get 6. Is this number a multiple of 3? 3 goes into it, right? 3 is literally in the number 6. It's 3 plus 3 makes 6, right? It adds perfectly to get into it. It's divisible by 3. And did you guys figure that out? Like when I divided 15 by 3, it worked out perfectly. There was no remainder because I got an answer of 5. You add the digits together, and it's got to be a multiple. It's got to be a multiple of 3. And 15 is a multiple of 3. It's 3 times 5. Most people know that. Okay, but let's do a bigger number. I'm going to make a number that is possibly divisible by 3, and it's going to be big. 1, 0, 0, 0, 3, 6, 0, 0, 0, 0, 3. Let's see if this works. And I'm going to put a 2 here. That's a huge number. What is that number? What is this number if I put commas in here? Thousands, millions, it's billions. It's 100 billion. That number is divisible by 3. The reason why, I add up all the digits together. 1 plus 0 plus 0 plus 0. Now, do I need to add zeros? No, so I'm just going to get rid of the zeros. So 1 plus 3 plus 6 plus the 3 plus the 2. So when I add these together, that's 4 plus 6 is 16, or is 10, sorry. That's 10 plus the 5 in the back here, so that makes 15. Is 15 divisible by 3? Yeah, it is. So that huge number is divisible by 3. That's how it works. You just add up the digits. A lot of people do not know that rule. Okay, does that make sense? Okay, let's go to lunch. Go to lunch, we'll come back, we'll learn the other 4 rules that we have here. Perfect, alright. Okay, what we talked about right before lunch was this divisibility test, right? If your last number in the house, we're talking about only these dividend numbers. If the number in the house ends with a 0, 2, 4, 6, or 8, it's divisible by 2. That means it'll work out perfect, you won't have any remainders. 3, this is the weird one we were talking about. That when you add up all the digits, so let's imagine that this number was in the house. Okay, it was the dividend number inside that long division house. If you add up the individual digits, and that number that you get when you add those together is divisible by 3, it's a multiple of 3, then the actual big number itself is divisible by 3. Okay? So this would actually work out, you could do this huge tier, this thing would go down forever, and you would eventually get to the remainder of 0 at some point, because it'll actually work out to be perfect. Okay? That's the idea. Okay? And if you don't trust it, try it on a calculator. It does work. You will not have any crazy decimals. They'll be perfect whole numbers across. Okay, now 4. The number 4. I should use red. So if you want to divide a number by the number 4, so the 4 is the divisor number. Here's what you do. You look at the last 2 digits. The last 2 digits of the number inside the house. Okay? If the last 2 digits inside that house are a multiple of 4, it's a multiple of 4, then it works. Okay, so let me explain. In fact, I'm going to use that number I just had a little bit ago. Okay, so that number is something like 10 billion 36 million 0, 0, 0, 0, 3, 2, or something like that, right? Whatever that number is, okay? The last 2 digits, is that number a multiple of 4? So think about 4. 4 goes 4, 8, 12, 16, 20, 24, 26, 28, 32, yes. The last 2 digits are 32, so it's a multiple of 4. So this thing will actually work. I'll be able to divide this whole thing and put a 4 on the outside, and you will not have any remainder left over. It works out perfectly. Just a weird little quirky rule, okay? So that's how it works. The last 2 digits are the important one. Just to warn you, like the number 100, I know that, what are the last two numbers there? The two digits at the very end of that number? Zeros, right? 0, 0. That number is divisible by 4. 0 is divisible by 4. So that's what you need to realize. Because when you add 4 or subtract 4, like, because you can keep adding 4 or keep subtracting 4, eventually you get to numbers that are divisible by 4, and 4 minus 4 is 0. So 0 is a number that's divisible by 4. So that's just a weird quirky one. That gets people sometimes when they see like the number 100. Alright, the number for 5. This one's easy. I think most people actually know the rule for 5. How is a number divisible by 5? It ends in a 0 or a 5. That's it. Last digit. Last digit is a 0 or 5. That's it. So like the number 100, that works. That's divisible by 5. So that's pretty easy. Okay. Any questions so far on these 4? I'm going to go one more number, and then we'll stop. Okay, the next number I'm going to do is your number divisible by 6? This check is very, very easy. If it's divisible by 6, it has the rules for the number 2 and the number 3. So what are the rules for 2 and 3? The rule for 2 has to end in a 0, 2, 4, 6 rate, and it has to, all the numbers when you add them together makes a number that's a multiple of 3. So that's the little quirky rule for 6. So basically what it is, if you're like going through and you're trying to divide by 2 or 3 and they both work, then 6 has to work. If one of them fails, then 6 does not work anymore. That's how it works. So that crazy number I just created a little bit ago, that 10 billion number, whatever that number was, 10 billion, 36 million, 32, right? That number is a multiple of 3, because when we added all those numbers, it made like the number 15 or something like that, or 12 or something like that, which is an actual number that's divisible by 3. And what is the last digit in that number? 2, right? So it's divisible by 2 as well. So yes, this number is divisible by 6. It will work. Because when you add these up, it's a multiple of 3 and it ends in 2. So 6 will work for that. Okay. Any questions with the rules? Now, you're probably wondering, why am I showing you these? Because they're not giving you the answer, right? It's not telling you what the answer is going to be in the end. It just helps you that you know it'll work out perfectly in the end. So I know that I'm not going to get a decimal in this problem. Or, ooh, it didn't follow the rule for 3. Like, I'm dividing it by 3, but it didn't follow this rule. I'm going to get a decimal here. I'm going to have a remainder. It's guaranteed. I know that I will have a remainder before I start. That way you're not, like, freaking out that you did something wrong. Alright, any questions with any of the stuff we've talked about today? Okay, tomorrow we'll talk about the rule for 9, the rule for 10, and then the rule for 11. Those are the weird ones. Those are the ones we need to talk about. Okay? Alright, the rest of the time, you can work on your page 19, 3 through 8, 15 through 20. That's the stuff we did yesterday. That was all multiplying stuff. Column methods, lattice method, I don't care which one you choose. If you have not done page 10 or 13, that is due. That is late. It needs to be turned in. Because I can't grade it if it's not turned in. So, the rest of the time is yours. You can work at your own pace. You can move around. You can sit wherever you need to. But make sure you are working constructively on something. Okay.